Hello, my name is Emmanuel Jjunju. I'm an engineer working with Sweco Norway. I work mainly with dams, hydropower, and other water-related infrastructure. I have been involved together with GIZ and the Nile Basin Initiative in developing the climate proofing guideline for water-related infrastructure, which I will be talking about in the next slides. My presentation is divided into three sections. The first section will focus on explaining the objectives and the scope of climate proofing. The second section will focus on the building blocks of the NBIs climate proofing approach. And the third section will go a little bit deeper in discussing climate proofing at the different phases of the infrastructure life cycle. The first objective of climate proofing is to look into the structure and operational integrity of water infrastructure under climate change. Dams, for example, are traditionally designed to withstand a particular or a given design flood. And in most analysis, when we look at determining the design flood, we have the assumption that there is stationality in the water series. But climate change is bringing new dimensions because the stationality seems to be disappearing, as in the design floods are expected to change due to climate change, and this causes challenges for existing infrastructure and means also new challenges for how to design new infrastructure. It means we have to take into consideration the impact of climate change, take into consideration the interventions that needs to be done on the design to make sure that they can function under climate change. We have other challenges that affect also dam safety, landslides, amongst other natural hazards that we also expect to get worse, especially if there is an increasing amount of water in the rivers. We don't only focus on increases in runoff, because in other areas you're going to have droughts that may also lead to other challenges. For example, sedimentation, the ability to actually flush out the sediments and make it very difficult for structures to achieve their service objectives, which is the next objective. The second objective of climate proofing is to ensure that the infrastructure delivers the services for which it is designed. Key among the services is irrigation, which is very important for food security, and a number of countries in the Nile Basin are highly dependent on irrigation for food production. So a reduction in water supply may mean a reduction in irrigation potential and therefore a big impact on food security. So this is something that needs to be focused on in designing infrastructure to make sure that we can harness any advantages where we have water increases, maybe provide storage or other mechanisms to ensure that crops can still be grown and that the food security is not threatened. Hydropower is an important component of the energy mix in most Nile Basin countries, and is very important for electrification, and is of course very dependent on runoff. And if there is a reduction in runoff, then it may be difficult to produce hydropower. If there's an increase in runoff, there's an opportunity, but there's also threats that have been earlier mentioned, like dam safety. So there is a real need to ensure that we deal with these threats from increases and also from decreases. Other threats I have probably not mentioned, like sedimentation, will also increase with increased runoff, landslides that might actually cause other dam safety related issues. So these are a number of issues that need to be looked at to ensure that the services continue. And then there is flood protection and other related factors like bridges, culverts, and erosion that threaten settlements. Already we see a number of landslide prone areas having more and more landslides due to an increase in runoff or in rainfall amounts. And this is probably going to be a theme that has to be looked at as we go forward. We have lots of bridges and culverts that have been designed based on historical time series, and there might be changes in future that may require a redesign or different approaches to ensure that this kind of infrastructure continues to function and provide the service for which it is designed. So that said, the overall scope of climate proofing, if I may summarize, is to enable the integration of climate change throughout the entire life cycle of infrastructure investment. And we have to do this all the way from policy, planning of individual projects, designing, and operation of the water infrastructure. We have to focus on services, structures, and maybe something even more important, the environment. The climate proofing guideline that has been developed is broad and offers a generic approach that can be applied across countries. That means that there may be different legal frameworks in different countries that may probably require different things or different aspects of water infrastructure to be looked at in different ways. That is not taken into consideration in this proofing guideline. It's more of a technical guideline that helps stakeholders doing climate proofing to actually be able to identify the risks, identify possible treatments, and I find a way to monitor whether the different treatments or the different interventions or adaptations are working. The guideline is designed for stakeholders doing climate proofing, and this means owners. Owners may be governments, private developers, operators who may just have a contract to operate different infrastructure, and also for professionals like consultants and other project development professionals who are usually used in carrying out planning, design, and operation of water infrastructure. The climate proofing guideline is adapted to the project development cycle of the Nile Basin. This cycle consists of 6 stages. The first one being creating of sector policy plans and regulation plans. This is usually something done by public entities or by the government. And then the next step is project identification, where project alternatives are studied and the best project is chosen. And then the third stage is project preparation. And on this stage, that's where we carry out the full feasibility analysis, field studies, environmental impact assessments, social impact assessments, among other studies, and also come up with a detailed design of the project. So here we are looking deep into the project, creating the components and making sure that they are robust. And then we have resource mobilization, which runs usually parallel to project preparation. The main objective of making sure that we have a financial closure for the project. And then construction, that is when we are actually putting down concrete and steel, then the physical infrastructure is being built according to the design. And here we also have ability to review a number of things as we put them down. And then we have the operation stage where the project is in place and it's running. And what we are saying is that climate change needs to be considered at each of these stages. We do not wait for the final stage when the project is in place. and start asking questions. Then we start already at the policy level. We consider climate change as we make the policies. We consider climate change as we choose the best project. Of course, it's not the only aspect we look at, or there are so many other aspects which are already looked at in the traditional development of a project, but we are saying climate risk assessment should be added as an extra step for each of these stages. Essentially, the activities related to climate proofing for each of these stages are similar. We start with scoping, where we basically are trying to identify the different climate threats or the threats due to climate change or the different risks. And once we have identified them, then we go on to assess the risk. In risk assessment, we basically put a score on each of these threats and try to find out how serious it is and whether it requires treatment or not. And here we are looking at the traditional risk assessment approach that has been well documented in many standards, where we look at the probability of a particular risk, and we look at the severity and find the product between the two that defines the level of the risk. And if we think that this is a risk that needs treatment, we identify the possible treatment options and analyze them to see if they are feasible, and then choose the best. In some cases, it may not be possible to choose a physical treatment, and that we may just need to monitor the risk and go on, or in other cases maybe we may need to go one step back and identify another project alternative or another treatment option. So it's kind of a bit of iterative, this risk treatment and risk assessment. And then for each stage, we would have to set up like a monitoring and evaluation plan that will be carried forward for the next level, because it may be that at sector level, we have decided that we will handle projects in a particular way, that the selection of a particular project should consider a particular treatment, and then at the identification, maybe we find out that it's not working as expected, and then we have to go back and review that decision. But essentially, we have the same stages or the same approaches that we scope at each level. We do the risk assessment, and then we find out the risk treatment options, and then we decide on the interventions and design them into the projects, and then move on, create a monitoring and evaluation plan, and move on to the next stage. A key difference between the stages is that the data available is not the same. So when you're making sector plans, you do not know really about the individual projects, but you have a general idea. For example, at the country level, what are the climate threats? So you use that data, and the analysis is a little bit rough compared to, for example, the project identification level. At the project identification level, you're looking at a number of different projects, and you're trying to select the best project. For example, maybe you're trying to build a dam for water supply in a catchment, and you have a number of sites that you think might be better, that might be probably offer a choice, and then you're going to check which is the better site. So at this level, you're not able to look so much into detail into the different components, but you are able to use some kind of a pre-feasibility study to say something about the climate, and maybe you're looking at using regional reports to glean some information about which project or which project formulation might be better. And then when you're done with that and decided that this project or project A is better than project B, you go on to the project preparation with that project that you've decided to take forward, and then you start looking deeper into the components. And at that stage, you might actually sometimes find that you may have to go back to the previous project, but in many cases maybe you don't have to, but then you probably have to then look at options for particular components. Should we have a longer spillway? Should we have a smaller spillway? Or should we use what material, and then so on and so forth. But always asking the key questions on climate proofing. And it's the same thing with the resource mobilization, construction, and operation and maintenance. So to focus a little bit more on these steps already from the earliest level of a project, and here I must say that this guideline is actually mostly focused from the project development stage and forward. We must establish what we call a risk and opportunity register. I have earlier talked about risk, which is basically looking at the negative aspects, like when you have increased stream flow causing maybe higher flood levels or drought. But there's also opportunities where an increased stream flow might actually result into opportunities for producing more electricity or storage that could be used during droughts. So we establish a matrix or what we call a register in this case, whereby we put out a list of all the climate stresses for each project alternative or each infrastructure alternative, depending on the stage where you are, and then define the threat or opportunity, and then define the potential loss or gain, and then compute the likelihood or the probability for it to occur, and this might be based on either qualitative analysis or it could be based on a quantitative analysis, which is possible for some risks. And then we will check out the severity, which is basically the potential loss should that occur. And then from this, we compute the risk or the opportunity. And then we have some color coding there for both the potential gain and the potential loss, which is a risk. And based on this color coding, we decide whether we need to treat the risk or not. And this is very important because at this level, you must involve the stakeholders to determine what level of risk they think might require treatment and what level of risk they feel that they can take forward and maybe monitor and find solutions as the project goes on, because it may not always be possible to find treatments for all the risks, or maybe because of economic or other limitations, or the stakeholders might decide that at some point in future they'll just build in a mechanism to deal with a particular risk. For example, if it's a dam, one may decide not to build a very long spillway, but decide, or very wide spillway to handle a particular flood, but decide to monitor changes in climate data and at some point in future maybe review the construction, or maybe just decide to choose a site where it's possible to build in an extra spillway. So there's this, so it's very important that stakeholders are involved. So this guideline does not provide particular information for you to make a decision, say this is what you should do, this is what the risk you should take, but stakeholders must be involved. We provide the scoring mechanism, but it's the stakeholders must be involved in actually deciding the level of risk that will be taken. Now, this risk register is updated as one moves through the climate proofing stages, or the project development stages. So at this earliest stage, as you go forward, a lot of things might change. Maybe you thought increased stream flow was going to be a big problem, and then you find a treatment, and then you redesign the project, and then at the next level you find that you've addressed that risk, and so you have to keep updating this risk register. More details about how to do this, of course, can be found in the documents that are going to be uploaded online. And of course, the discussions between a forum that is going to be put up will also provide an opportunity for finding help in how to do this scoring. Just to summarize, the differences in risk assessment for the different stages are as follows. The risk register setup does not change with the decision-making context or with our project stages. It just evolves. The key difference for the different contexts is how the potential risk is defined. At the identification stage, one may deal with issues in a general way, but while at the project preparation stage, the focus moves to specific components. The provided templates cannot anticipate all the different permutations of risk and components, and this should be determined project by project. A little bit more about risk treatment, because this is very important, because it's through this risk treatment where we identify what to do to deal with climate threats. So the first step is to identify the risk treatment options, and the guideline has tried to list typical threats to water infrastructure, and there's lots of literature and references that are also provided that can help the users of the guideline to identify risk treatment options for the different risks. And once you've identified them, then you assess adaptation measures, and this might include some economic analysis, because it's not only about identifying a measure that might solve the risk, but is it actually doable? And if it's not, then like earlier said, the stakeholders may have to decide whether it's a risk that they will be able to handle now, or they will be able to just monitor and handle at some point in future, but at least they're aware. And that's where the risk communication comes in, that a lot of times it may not be possible to actually have a physical solution, and then it might be necessary to actually just communicate the risk and monitor and review as the project goes on. So to summarize, there's a number of treatments in this particular case, is that you can decide to avoid the risk by just not doing anything. You can accept the risk, and in some cases also increase the risk. You must remove the risk source, or you might change the likelihood of the risk by creating some intervention measures. And you might also change the consequences by creating some physical measures so that even if you don't change, for example, at the dam design to handle flooding, and or maybe to increase storage so that a downstream community is protected from flooding, you instead go for protecting that community downstream. So then you know that in case it happens that a huge flood is released from my future infrastructure, the community downstream is not affected. So there's different ways you can do it. You can do this, and it could also be others like sharing risk or just retaining the risk and continuing. But it's important that it is communicated, and that in the monitoring plan, the solutions were clearly explained, or the adaptations are clearly explained and monitored, and then should anything change at some point in future, then new interventions are made. Like I said earlier, climate change is like an always moving goal, and we do not expect this stationarity to continue, and so it may not always be possible to come up with a design that will handle everything that is expected to happen in the next 50, 100 years of the life of the project. And such a design might sometimes become too expensive. So it might, in many cases, be necessary to just build in ways to monitor and ways to improve or identify sites and solutions that are adaptable or that can be changed as time goes on. I've said a lot about monitoring and evaluation as a very important way to go forward, because we may not be able to anticipate everything. Stakeholders should be involved, and there must be a monitoring plan, and there must be a way to actually follow up this plan and identify threats and find out how to deal with them as they come. And in many cases, it might be also for projects that are already running necessary to decide whether a comprehensive climate risk assessment is necessary during the next project cycle stage, and that is during the project development, but also during the operation of the project. And even when a project is in operation, it's important to always update this risk register so that we know where we stand and find a way to deal with climate change. It is not possible to cover all the aspects of the climate proofing guideline in this short introductory video, and there is a lot of information that has been left out, but I hope that this presentation has provided you a teaser of what the climate proofing guideline is all about. I am hoping to be available as one of the people who has developed this guideline to help on the online forum that the GIZ and the Nile Basin is creating to support future users who want to do climate proofing for their projects. So it would be nice to hear some feedback and some questions as time goes on. And as I said earlier, there's a lot of information in the text that are going to be provided and online guidance. And I hope that will be useful for you to carry out climate proofing on your projects. Thank you. I think I'll stop now, and I wish you the best as you use this guideline for your projects.